On the night of July 1st, 2025, astronomers operating the Atlas telescope in Chile detected an unusual object in the night sky, a tiny moving dot located just beyond the orbit of Jupiter. Initially, it appeared to be a standard celestial body, such as an asteroid or a comet, following the familiar pattern seen within our solar system. However, within hours of its detection, scientists noticed something peculiar about its motion. It didn't behave like typical solar system objects. Instead, its speed and trajectory hinted at a rare and extraordinary origin. It was quickly recognized as an object not native to our solar system, but rather a visitor from interstellar space, making it only the third confirmed interstellar object ever observed after Oumuamua, 2017, and 2I Borisov, 2019. Now officially named Comet 3I Atlas, this discovery immediately captured the attention of the global astronomical community, marking a historic moment in the ongoing exploration of objects from beyond our solar neighborhood. What makes 3I Atlas truly exceptional is its speed and trajectory, which clearly indicate it is an interstellar object, not gravitationally bound to the sun. While most objects in our solar system, like planets, asteroids, and comets, follow elliptical orbits, 3I Atlas is traveling on a hyperbolic path, meaning it's just passing through and will not return. Make sure you stick around, and if you're into deep space mysteries, consider subscribing so you don't miss what's coming. Its velocity is about 70 kilometers per second relative to the Sun, which is far greater than the solar escape velocity at its distance. This confirms that the object is not captured by the Sun's gravity and must have originated outside our solar system. Moreover, its orbital eccentricity, a measure of how stretched an orbit is estimated to be greater than 6, far above the value of one that defines the boundary between solar-bound and unbound, hyperbolic orbits. This high eccentricity is a strong mathematical indicator of interstellar origin, solidifying 3I Atlas's status as a true interstellar visitor. Soon after its discovery, astronomers observed a faint fuzziness around 3I Atlas, a sign that it was not just a rocky asteroid, but an active comet. This fuzziness, or coma, forms when sunlight heats the icy surface, causing volatile ices to sublimate, turn from solid to gas, releasing dust and gas into space. Follow-up observations from telescopes around the world confirmed the presence of a coma and a short tail, both of which are classic features of an active comet. This indicated that 3I Atlas was reacting to solar heat just like traditional comets in our solar system, proving its icy composition. Based on this behavior, the International Astronomical Union, IAU, officially classified the object as a comet, not an asteroid. With its cometary nature confirmed, the object was given a formal name, C 2025 N1 Atlas. This name follows the IAU's standardized naming convention for newly discovered comets. C/ indicates it is a non-periodic comet, i.e., it's not expected to return. 2025 is the year of discovery. N refers to the first half of July. Each month is split into 2 halves, with letters assigned to each. The letter I is skipped to avoid confusion with the number 1. 1 indicates it was the first such object discovered during that period. Atlas credits the survey that discovered it. This naming process not only formalizes the discovery, but also provides key information about when and how the object was found, and highlights its non-returning, one-time nature, reinforcing that this is a rare opportunity for observation. Estimates of 3I Atlas size suggest it could be anywhere from 5 to 50 kilometers in diameter, potentially making it the largest interstellar object ever observed, significantly bigger than both Oumuamua and Borisov. At the time of its discovery, it was about 670 million kilometers from Earth, located just inside Jupiter's orbit. Despite being extremely distant, it was still detectable thanks to sensitive telescopes, although it was roughly 2.5 million times fainter than the pole star. 3I Atlas is expected to reach its closest approach to the Sun, perihelion, around October 30th, 2025, at about 206 million kilometers from the Sun, just inside the orbit of Mars. However, it will be positioned on the far side of the Sun from Earth during this time, which will limit direct observations. Starting in early December 2025, the comet will reappear from behind the Sun, allowing astronomers another window for observation. It should remain visible to large telescopes until early 2026, after which it will fade as it speeds away, returning to the darkness of interstellar space. Before 3I Atlas, only 2 interstellar objects had been confirmed, and both were quite different from each other. Oumuamua, discovered in 2017, had a clearly interstellar trajectory but behaved strangely. It showed no visible coma or tail, typical signs of cometary activity, yet experienced unexpected acceleration, suggesting some form of outgassing or other forces. Its unusual, elongated or flattened shape and mysterious behavior sparked many theories, including exotic ices or even artificial origin, though the latter is now mostly dismissed. 2I/Borisov, discovered in 2019, was a more typical comet with a bright coma and long tail behaving much like comets we see in our solar system. Its discovery confirmed that interstellar comets with familiar characteristics do exist. Together, these 2 objects demonstrated that interstellar visitors can be wildly diverse, some rocky and mysterious, others icy and familiar, setting the stage for 3I Atlas to provide critical new data. Comet 3I Atlas offers a crucial third data point for astronomers studying interstellar objects ISOs. With only Oumuamua and Borisov previously observed, it's been difficult to determine whether these visitors represent common types or rare exceptions. If 3I Atlas behaves like a typical icy comet, showing clear coma and tail activity, it would suggest that Oumuamua's unusual features were an anomaly, perhaps caused by unique circumstances like fragmentation or extreme space weathering. However, if 3I Atlas exhibits any unusual behavior, such as unexpected acceleration or strange chemical signatures, it might indicate that Oumuamua was not so unusual after all, hinting at a wider variety of interstellar object types. Studying 3I Atlas helps scientists better understand the range of physical and chemical properties of interstellar visitors, advancing knowledge about the diversity of objects traveling through the galaxy. By closely analyzing the chemical composition of 3I Atlas and comparing it with that of 2I/Borisov and comets originating within our own solar system, scientists can gain valuable insights into the similarities and differences in planetary system formation across the galaxy. If 3I Atlas ices and organic materials closely resemble those found in local comets, it would suggest that the processes that form comets and planets are largely universal. On the other hand, significant chemical differences could reveal that each planetary system develops unique chemical signatures influenced by its specific environment and history. This kind of comparative study offers a rare window into how planets and cometary bodies form and evolve around other stars, helping to unlock mysteries about the origin of planetary systems beyond our own. The Vera C. Rubin Observatory, currently being completed in Chile, is poised to revolutionize the discovery of interstellar objects like 3I Atlas. Equipped with a massive 3.2 gigapixel camera and an extremely wide field of view, Rubin will be able to survey the entire night sky every few days. This unprecedented capability means the observatory can spot fast-moving transient objects, including interstellar visitors, much earlier and more frequently than ever before. At its first look event, Rubin already discovered over 2,100 new asteroids within just hours of operation, showcasing its power. Once fully operational, Rubin is expected to dramatically increase the detection rate of asteroids, comets, and especially interstellar objects, potentially enabling scientists to discover multiple interstellar visitors every year or decade, a huge leap from the current pace of just a few detections per decade. The discovery of 3I Atlas marks the beginning of a transformative era in the study of interstellar objects. Thanks to advancements in telescope technology, improved global survey networks, and upcoming instruments like the Rubin Observatory, astronomers are now better equipped than ever to detect and study these rare cosmic visitors. With the expected increase in discovery rates from a handful every decade to potentially several each year, scientists will have a much larger sample of interstellar objects to analyze. This growing dataset will allow them to categorize ISOs by type and origin, trace their likely birthplaces in other planetary systems, understand how planets and comets form and are ejected into space across the galaxy. As 3I Atlas continues its journey through our solar system, in the coming months, astronomers worldwide are closely monitoring it, hoping it will reveal new secrets about the cosmos. This heralds an exciting future where catching visitors from beyond our solar system becomes a regular, insightful part of astronomical research. If you're into deep space mysteries, consider subscribing so you don't miss what's coming.
For centuries, humanity has looked to the sky, searching for answers. We've built theories, written equations, and tried to understand our place in this vast cosmic puzzle. But now, everything we thought we knew, our physics, our cosmology, our understanding of space and time, has been shaken to its core. Why? Because what the James Webb Space Telescope has just revealed wasn't supposed to exist. Galaxies that are far too old, planets that are far too large, structures too perfect, and a signal, steady, rhythmic, and unnatural, that doesn't fit into any known astrophysical model. This isn't just another discovery. This is a collision between what we believed and what actually is. The James Webb Space Telescope may have just delivered the most profound warning and invitation in human history. And if it's real, everything we thought we knew about the universe is wrong. In a series of deep field observations, the James Webb Space Telescope captured some of the most detailed images of the universe we've ever seen. But it wasn't just beauty hidden in those images. In the galaxy cluster AEL 2744, researchers found perfectly aligned light points and symmetrical structures, patterns that don't belong in the chaotic world of galactic evolution. Then, in NGC 1365, a spiral galaxy with unusual motion patterns suggested gravitational behavior that contradicted everything we thought we knew about our most basic models, and it didn't stop there. Similar anomalies began to appear across multiple images. The farther Webb looked, the stranger the universe became. Patterns repeating across billions of light years. Structures showing precise geometric symmetry in a cosmos that was supposed to be random. Scientists tried to dismiss it as coincidence, but there were too many, too frequent, too perfect. Slowly, the whispers began. Maybe we're not seeing randomness at all, but a form of order we just don't yet understand. One of the many targets of the James Webb Telescope was an exoplanet named HIP 65426b, located hundreds of light years away. What it revealed left astronomers completely speechless. This planet is 7 times the mass of Jupiter, orbits its star 3 times farther than Neptune, and exists around a star barely 15 million years old. By all known theories of planetary formation, this planet shouldn't exist. There's no visible protoplanetary disk, no leftover material, no gravitational explanation for how such a massive world could form so far out, so quickly, and remain stable. Some researchers have even begun to speculate. What if this planet isn't a product of its current system at all? What if it's a remnant of a previous cycle? A relic from a star system that came before, somehow transplanted, reused, or deliberately placed? For now, there are no answers. Just a planet glowing at over 1,000 degrees Celsius, suspended in a system that shouldn't have had time to build it. But perhaps the most surreal discovery of all was when the James Webb Telescope imaged something called an Einstein ring, a gravitational lens caused by a massive foreground galaxy bending the light of a galaxy directly behind it. But this one was nearly perfect. A full, uninterrupted circle of light with such mathematical symmetry that even the most experienced astrophysicists were left stunned. For this image to exist, the alignment between the 2 galaxies must be exact, down to fractions of a degree, across billions of light years. That's not just rare, that's statistically improbable on a cosmic scale. While gravitational lensing is a known phenomenon, the degree of perfection here is raising far more questions than answers. Could this be a hint of some deeper symmetry embedded in space-time itself? A sign that the universe isn't as chaotic as we thought, but instead governed by a geometry we've barely begun to perceive. But no discovery has shaken the scientific community quite like this. The James Webb Telescope has found massive, mature galaxies forming just 180 million years after the Big Bang. Sounds far away, right? In cosmic terms, though, it's impossible. Galaxies shouldn't have had enough time to grow to these sizes, organize themselves into spiral structures, or produce the brightness that Webb has observed. The universe just got a whole lot stranger. The James Webb Space Telescope has made a discovery that's shaking the very foundations of our understanding. It has captured galaxies as large as the Milky Way, fully formed, stable, and thriving, when the universe should have still been a chaotic sea of gas and dust. This has cosmologists scrambling, because if these galaxies are truly as old as the data suggests, then our entire theory of how the universe began may be completely wrong. For decades, the Big Bang theory has been the cornerstone of modern cosmology. But now, some researchers are openly questioning its validity. If these galaxies existed so soon after the Big Bang, then maybe, just maybe, we're looking at a universe with a history far older than we ever imagined. In a region far from any major galaxy, the Webb telescope detected something completely unexpected. A gravitational lens effect in an area of space where, at first glance, nothing should be. No stars, no galaxies, no black holes. Yet, light from distant galaxies is bending, curving, and distorting, as if something massive is lurking in the shadows. At first, astronomers thought this was just dark matter, a mysterious form of mass we can't see, but which exerts a gravitational pull. But the intensity and precision of this lensing effect challenge even that theory. The distortion is too strong, too localized. It behaves more like a solid structure with defined mass, symmetry, and edges. Could it be a cluster of dark matter condensed into a shape we don't yet understand? Or could this gravitational echo be something even more radical? Something older, something built, still silently warping space itself? Among the most controversial findings from Webb is the detection of a massive intergalactic filament, a stretch of galaxies and matter aligned so precisely that it forms a structure over 1 billion light years long. We've seen filaments before, part of the so-called cosmic web, but this one is different. The alignment, the density, the repeating voids, it almost looks like a grid, like a framework laid across the universe. Mainstream cosmology says these patterns are the result of gravitational attraction over billions of years, but the symmetry here is hard to ignore. The galaxies follow parallel paths. The dark matter clumps at exact intervals. Even the redshift readings from this region show a wave-like regularity, as if the very fabric of the cosmos in this zone was intentionally engineered. Some scientists remain cautious, arguing that our brains are wired to find patterns, even where none exist. But others are beginning to wonder, what if the universe did have a builder? What if intelligence once shaped it? If that's the case, then this could be where we start to see the fingerprints of that intelligence. And then, there's the most mind-bending idea yet. What if dark matter, long thought to be invisible and inert, actually carries information? Not data, like we understand it, but something deeper, a kind of cosmic memory. Across multiple Webb observations, galaxy clusters have appeared in arrangements that seem to echo distant, earlier formations, almost like a cosmic echo. What if dark matter isn't random, but instead preserves traces of past cosmic structures? What if, as the universe expands, this hidden matter holds on to gravitational imprints, shaping future galaxies based on these ancient alignments? This idea blurs the lines between physics and philosophy, suggesting that the universe might not just have a beginning, but also a memory that could mean every spiral, every cluster, and every void is part of a design far older than we ever imagined. But perhaps the most spine-chilling finding yet is one that few are willing to discuss. During a deep field scan in a void sector, the James Webb Space Telescope recorded a series of pulses, light fluctuations that were too regular to be random, too faint to come from any known star. The signals didn't match the frequency of pulsars or quasars. They repeated at exact intervals, and then vanished completely. At first, scientists thought it was an error, perhaps a reflection, interference, or a processing glitch. But after running the data through independent systems, the pattern remained. The origin point showed no stellar mass, no nebula, no heat signature, just a steady flash, precisely timed as if it had been measured or timed. For now, NASA has declined to comment, but behind closed doors, researchers are asking a question that has echoed for decades. What if it's a message, not meant to be received, but simply noticed? And if so, who or what was meant to see it? The James Webb Space Telescope was built to reveal the past, peeling back the layers of time to show us what the universe looked like billions of years ago. But in doing so, it may have shown us something even deeper, that we are not just observers of the cosmos. We are part of a system far older, more precise, and more deliberate than we ever imagined. Galaxies that shouldn't exist, planets that defy gravity, signals without sources, structures that seem to mirror intelligence. This isn't random noise. This isn't just science fiction flirting with curiosity. These are data points, real, measurable, undeniable, that challenge the very fabric of our understanding. And if the patterns are real, if the pulses are deliberate, if the universe remembers, then we must confront the most unsettling possibility of all. We have never been alone, not in time, not in space, not even in thought. Because what James Webb may have just uncovered isn't just a map of the early universe. It may be a message, left behind, or a system that was waiting for us to look deeper. And now that we have, the world may never see the stars the same way again. So now, we ask you, are these discoveries signs of something more? Or are we just seeing reflections of our own desire to find meaning in the void? Let us know what you believe in the comments. And if you want to keep exploring the cosmic riddles that the rest of the world is just beginning to notice, subscribe and turn on the notification bell. Because the next image from James Webb might not show us where we came from, but where we're meant to go. We'll see you beyond the veil.